Hey guys, this is AF and in this video we are going to be discussing indices. For this video we are only going to be discussing what indices are and the different rules and laws related to them, which is basically the entire syllabus content for this chapter. And in another video which will follow this one, we are going to be talking about different past paper questions which are going to give you a very good idea of how this chapter is tested. And this is one of those chapters which appear very frequently on the actual exam, so make sure that you have a firm grasp over it. So let's move on and discuss what's meant by the term indices. So we know that multiplication is a more elegant way of expressing a certain case of addition, that case being when you are adding a number to itself again and again and again, we can express that in form of a multiplication. For example, if I have this addition, which you can see right now, I can express it as 4 multiplied by 4, where the latter form is going to be a better way of expressing the same piece of information. 4 multiplied by 4 I know can be expressed as 4 squared, and 4 squared is in the index form, and index is just the singular of indices. So from this we know that multiplication is a way to express a certain type of addition where the addition is about adding a number to itself, whereas indices is the form of expressing a certain case of multiplication where a number is being multiplied with itself in a more elegant, shorter and easier to handle way. So let's move on and dissect this index form. So if we have a number a which is being multiplied with itself a total of b times, we're going to express this information as a raised to the power b. So this notation is basically read as a to the power b, where b is in superscript. So this a in this case is going to be called the base, and this b is called the power or the index or even the exponent. So either three of those terms can be used. So basically the index form consists of two numbers, one the base and two the exponent or the power. Moving on, let's move into the different rules of indices. So this rule basically tells us that if we have a number with the negative power, it is going to be equal to the reciprocal of that expression, but we're not going to write the negative sign this time. The negative sign is going to be removed. So an example of it could be that if I have 3 which is raised to the power minus 2, where minus 2 is obviously a negative number, I can express it as 1 over 3 squared, where 3 squared is the reciprocal of 3 raised to the power minus 2 without the negative sign in the power. So as I said earlier, if a number has a negative power, it can be expressed as a reciprocal of that very number, but this time we're not going to write the negative sign with the power. So 4 raised to the power minus 3 is going to be equal to 1 divided by 4 raised to the power 3, and 5 raised to the power minus 1 is going to be equal to 1 divided by 5. So the entire chapter of indices is just dealing with a bunch of these rules and knowing when and where to apply them and how to simplify different expressions. So while in this video we're going to be dealing with all the different rules, how to solve the questions and how to simplify expressions, etc., these things are going to be dealt in the following video. Let's have a look at another rule. So the b root of any number a is going to be equal to that number a raised to reciprocal of b. So at first I know this rule sounds a little too much, but once you get the gist of it, all indices rules are very simple, and with a little bit of practice you're going to become very familiar with them and they're not going to be difficult anymore. So if I have the third root of 4, this is how this notation is read, the third root of 4, that's what we call it, is going to be equal to 4 raised to the power reciprocal of 3. Let's have a look at another example. The square root of 5. Now, if I have a square root, a number 2 is not usually written here. So if there's no number written and you just have this root sign, this means that there's going to be a number 2 here, but it's just a tradition not to write this 2, but this is still read as a square root, and this is going to be, this non-existent number here is basically 2. So the second root of 5, we're going to be calling it the second root of 5 instead of a square root to make things easier for us. So the second root of 5 is equal to 5 raised to this reciprocal of 2. Moving on, if we have the fifth root of 6, we can write it as 6 raised to the reciprocal of 5. Moving on, let's discuss a few more rules. So another rule says that a raised to the power b multiplied by a raised to the power c is equal to a raised to the power b plus c. So let's see why this rule is true. Alright, so if we have this expression where a is multiplied with itself b times, and then that expression is multiplied with another expression which consists of a being multiplied with itself c times, in total it's going to be a multiplied with itself how many times? B plus c times, and therefore the power of a is going to be b plus c, and now we know that this rule is actually true and we understand the reasoning behind it. Let's have a look at a few examples. 2 squared multiplied by 2 raised to the power 4 is going to be equal to 2 raised to the power 6 because 2 plus 4 is equal to 6. Similarly, 3 raised to the power 7 multiplied by 3 raised to the power 8 multiplied by 3 raised to the power 2 is going to be equal to 3 raised to the power 17 because 17 is equal to 7 plus 8 plus 2. So by this example, you know that this rule is not true for just 2 terms, but for any number of terms. The only condition is that the bases must be the same, and the powers, well, they can be same or they can be different, but you just have to add them in the end. Another example says 5 multiplied by 5 multiplied by 5 raised to the power 3 is equal to 5 raised to the power 5 because 3 plus 1 is equal to 5. Let's have a look at another rule. The next rule says that if I have a number a raised to the power b divided by a raised to the power c, it is going to be equal to a raised to the power b minus c. So let's look at the reasoning behind this rule. So in the first rule I said that if a number has a negative power, I can express it as a reciprocal of that number, but this time I'm not going to be writing the minus sign with the power. So if we go the opposite way, this means that if I have the reciprocal of a number, I can express it as the number with a negative power, right? So basically I can express 1 over a raised to the power c as a raised to the power minus c. So a raised to the power b divided by a raised to the power c becomes a raised to the power b multiplied by a raised to the power minus c. And now you just have to apply this rule that we discussed right now, and when you are going to add b and minus c, you get a raised to the power b minus c. Another thing that you need to understand from this reasoning is that when I talk about the different rules of indices, they cannot be applied in just one direction but rather both directions, because all of these rules are in the form of an equation, and so you can always change from one side of an equation to the other side of the equation, and it's not necessary which side you're going to be given with and which side you need to go into. So remember to use these rules both ways. If I have 2 raised to the power 3 divided by 2, if I don't write the power of a number, this means that the power is 1. Therefore, I'm going to say that the answer is 3 minus 1, which is equal to 2. So the answer would be 2 multiplied by 2, or 2 squared. Another example says 2 raised to the power 5 divided by 2 raised to the power 3 is equal to 2 squared, because 5 minus 3 is equal to 2. According to another example, 7 squared divided by 7 is equal to 7 because 2 minus 1 is equal to 1. Moving on, let's have a look at a few other rules. So the next rule says if I have a raised to the power c multiplied by b raised to the power c, I can express it as an expression a multiplied by b raised to the power c. Now in the previous rules that we discussed, the bases were constant. When we were multiplying the two numbers with the same bases and different powers, or when we were dividing the two numbers with the same bases and different powers. But in this rule, we now have different bases but the same power. So if we have different bases and the same power, and the two terms are being multiplied together, we can write it as the product of the bases raised to the common power. An example says 2 raised to the power 3 multiplied by 3 raised to the power 3. So since I know that the bases are different but the exponents are the same, I know that this rule is going to be applied and I can express it in this form, which is going to be equal to 6 cubed. Moving on, if I have two numbers 4 squared multiplied by 2 squared, it is going to be equal to 4 multiplied by 2 with 2 as the exponent of the whole expression 4 multiplied by 2. So it's going to be equal to 8 squared, and 7 raised to the power 5 multiplied by 5 raised to the power 5 is going to be equal to the expression 7 multiplied by 5 with 5 as the exponent of the entire expression. So the next rule says that if I have a number a raised to the power c divided by another number b raised to the power c, it can be written as the expression a divided by b with c being the power of the entire expression. Again, for this rule, the bases are different, but the powers or the exponents are going to be the same. Let's have a look at the examples. So 4 raised to the power 3 divided by 9 raised to the power 3 is equal to the expression 4 divided by 9 raised to the power 3. 4 squared divided by 2 squared is equal to the expression 4 divided by 2 raised to the power 2, and since 4 divided by 2 is equal to 2, I can say that this expression is equal to 2 squared. Moving on, 7 raised to the power 4 divided by 3 raised to the power 4 is equal to the expression 7 divided by 3 raised to the power 4. Let's move on to the last two rules for this video. A rule says that if I have inside the bracket a number a raised to the power b and the power of the bracket itself is c, then I can express it as a raised to the power b multiplied by c. Let's have a look at an example. If we have 2 squared and the entire expression has a power of 3, then we are going to write it as 2 raised to the power 2 multiplied by 3, which is equal to 6. So the expression is going to be equal to 2 raised to the power 6. If 3 raised to the power 3 has the power 9, then it's going to be equal to 3 raised to the power 27, since 27 is equal to 9 multiplied by 3. And if 9 raised to the power 4 has the power 2, then it's going to be equal to 9 raised to the power 8, since 2 multiplied by 4 is equal to 8. Now, a few points to remember for this rule are that this number must have a power itself, and this number outside is the power of the entire bracket and not a part of it. It's not the power of b or it's not the power of a, it's the power of a raised to the power b. Let's move on to the last rule, which is that any number raised to the power 0 is equal to 1. Now you must be wondering, why is that so? If I have a number a raised to the power b divided by a raised to the power b, the number is being divided by itself, so the answer is going to be 1 obviously. So we know that this part of this equation is true already. And by the rules of indices, we know that a raised to the power b divided by a raised to the power b can be written as a raised to the power b minus b, because this was one of the rules that we discussed earlier. And this expression is equal to a raised to the power 0. So a raised to the power 0 is equal to this expression, and since this expression was equal to 1, I know that a raised to the power 0 is equal to 1 as well. So if I have any number, regardless of the fact whether it's a rational number, an irrational number, a fraction, an integer, a natural number, when it is going to be raised to the power 0, the answer will always be equal to 1. So 2 raised to the power 0 is 1, 7 raised to the power 0 is 1, 27 raised to the power 0 is 1, and any real number raised to the power 0 is equal to 1. That's all for the different concepts of indices. I hope that you found this video helpful. In another video, we are going to be discussing the past paper questions for indices, and together these two videos are going to give you excellent preparation for your CIEs. Goodbye and thank you.